Okay, let's do this. Let's talk about factoring. We're going to talk about factoring two parts today. So factoring simple trinomials. We're also going to talk about factoring difference of squares. Pardon me. Difference of squares is actually, it is factoring simple trinomials. I'm just going to show you a shortcut is all, okay? So up first for simple trinomials, when I say a simple trinomial, what does that even mean? Well, if standard form of our quadratic relation is y equals ax squared plus bx plus c, a simple trinomial is when we have an a value of 1. So an example may be y equals x squared plus 6x plus 9. That's a simple trinomial. A complex trinomial is when the a value is not 1. And normally we would spend time on that in class, but guess what? That's pandemic switch, and we are not going to do complex trinomials. So you'll have to do it next year. If you are feeling really, really good about the stuff that we're doing and want to look ahead, I encourage you to take a look at complex trinomials in your textbook or online. I am not assigning it. I am not assessing it, but that's something that you'll have to learn quickly next year. So just a heads up on that. So to start, we're just going to do a little bit of math together. I want you to tell me two integers. So remember, integer is no fraction. It can be positive or negative. What are two numbers that multiply to 6 and add up to 5? Three and 2. Yeah, Opie and Anna have got it. 3 times 2 is 6. 3 plus 2 is 5. That's that. Let's go ahead and try this for the rest of this table. We're going to do a couple together. You'll do a couple on your own. I need to pull out my line paper here. So let's do our next one, 20 and negative 9. So all of a sudden we've got a negative here. That's different. If it helps, make a list of all the factors. So what I'll do sometimes is I'll say, okay, what are all the factors of positive 20? They are 1 and 20, 2 and 10, 3 is not a factor, 4 and 5, and that's it. Now I need to have it add to negative 9. So I'll look here and say, okay, 1 plus 20, nope. 2 plus 10, nope. 4 plus 5, well, 4 plus 5 equals positive 9. How do I get negative then? If it's a positive number, yeah, Anna, okay? A positive number means it's either positive times positive or negative times negative. Good job, OP. So all of a sudden, negative 4 and negative 5 equals negative 9. And those are my two integers. Take a moment or two and try the other 4 problems here. Okay, CL, I'm going to work through some. If you're feeling good on these, go ahead. Okay, CL, let's do C. So my product is negative 21. I need two numbers that will multiply to negative 21. So I could have negative 1 and 21. I could have 1 times negative 21. Are you with me on this, like setting up our factors? Yes, perfect. Not because I think that you won't be. I just want to make sure that I'm not missing the step that's a stumbling block. Okay, 2 is not a factor. I could have 3 times negative 7 or negative 3 times positive 7. 4, 5, 6. That's all my factors for negative 21. So now when I add them together, let's see what I get for each of these factor pairs. Negative 1 plus 21 gives me positive 20. 1 plus negative 21 gives me negative 20. 3 plus negative 7 is negative 4. -3 plus 7 is +4. So I'm looking for two numbers that multiply to -21 and add up to +4. That's my last factor set right here. So these two integers are -3 and 7. We don't know why we're doing this yet. Good, great. I just need you to be able to do this. Does anyone want me to walk through D, E, F right now? Or do you want me to be quiet for a minute so you can finish it? I'm going to be quiet. Once you've got them, maybe you can throw the answers in the chat for me. Even if you see someone submit them already. Give me more answers. Love it. Okay, so I see a couple people giving answers for E, -1 and -1. You got it. I saw F as -2 and -8, right? No one's giving me an answer for D. Yeah. 4 and -5. Good. So we've explored a little bit of the relationship between product and sum. If you feel kind of okay about this chart, you're going to feel kind of okay about factoring simple trinomials. I promise. So how do we actually factor a simple trinomial? Here are some steps. Honestly, don't even worry about this chart, okay? This is something that we would structure to get ready for complex trinomials. But since we're not doing complex trinomials, you can leave this for now. I also would have normally taught you an entirely different method for complex that I like a lot more. And there's even been some news in the last few months that someone discovered a new way to factor complex trinomials based on a Sudbury professor. So there's a little Canadian connection. All right. So if we look at our expression of ax squared plus bx plus c, we know that a is 1. Okay, our first factor is always going to be factor out the greatest common factor. I may throw a curveball at you where the a value is not 1, but there is a common factor we can pull out. So then 2, find two integers that multiply to c and add to b. And then we're going to put integers into the brackets. For example, x minus s and x minus t. Oh my God. That's actually going to be, yeah. I'm just going to leave those as blank right now. So x plus something and x plus something. And then if you're not sure, reverse it. Do FOIL and see if you come out with your original expression. So maybe 30 more seconds, and then we'll try this out. All right, so factor fully. If we look at our first expression, p squared plus 9p plus 20. Is there a common factor? Our a value is already 1. We're good. We're going to go into our next step. So I'm going to look at c, which is 20. And I need to find two numbers that multiply to 20 and add to 9. And which factor pair would I choose here? 4 and 5. Great. So then when I have my factors written like this, all I do is I take my two integers, guys. So that would be x plus 4 and x plus 5. And guess what? That's it. If I were then to FOIL, to check it, to do first inside, outside, last, that would give me x squared plus 5x plus 4x plus 20, which would simplify, oh, sorry, p. Oh my goodness, I'm using the wrong variable, guys. Which would give me p squared plus 9p plus 20. It's my original expression. Ta-da! Let's try the next one. X squared minus 9x plus 20. Oh, 20 again, eh? Eh? So we're going to list all my factors. 1 and 20, maybe negative 1 and negative 20. 2 and 10, negative 2 and negative 10. 4 and 5, negative 4 and negative 5. Which ones? Yeah. So can you guys write it as factored form for me? Way to go. So I had x minus 4 and x minus 5. So many good answers coming in. Thank you, all of you. We're done that one. Try C by yourself. Apparently, we just used a lot of 20s on this one. So you're working away, but so am I. This time I need to multiply to negative 20. So I did negative 1 and 20, or 1 and negative 20. 2 and negative 10, negative 2 and 10, 4 and negative 5, negative 4 and 5. That's my pair right there. So my factored form would be m minus 4 times m plus 5. Feeling good? Let's flip onto the back side of this page. Oh, look at all this more practice. Okay, I would actually like to leave D, E, and F for you to try on your own. And the answers are posted on our content. I'm going to put the answers up here quickly. So for those of you watching at home, press pause. Those of you that are watching live, maybe jot down the answers, but I'd like you to try this later, okay? So that's going to be m minus 11 and m plus 2. R minus 27, R minus 3. and w minus 7w plus 2. Great. Okay, I wanted to get on to 3 because it's the same thing, but there's that one extra step. So what was step 1 that I wrote on the other side of this page? The first step we have to do every single time. GCF, you got it. So if I look here, first I'm like, A's not 1. How am I supposed to factor this, Ms. Morton? Well, let's put our greatest common factor first. I see, oh, they can all be divided by 5. So I'm going to rewrite it as 5 times x squared plus 8x plus 12. Now, factor our simple trinomial inside the brackets. So it'd be 5 times something times something. 2 integers that multiply to 12 and add up to 8. Give me my full expression. Don't forget our greatest common factor, Anna. Good, Opie. Oh, Opie, you forgot your addition and subtraction signs. Kendra, good, you're missing a close bracket. So that would be x plus 2 times x plus 6. Could I have written it as 5 times x plus 6 times x plus 2? Yes. Same thing. Try number 2, please. Yeah, that's good, Kendra. So you guys are going to get 2 times x squared minus 7x plus 12. Then when you factor that, you're going to get 2 times x minus 3 times x minus 4. C, D, E, and F are the same thing. However, now we're adding in a bit where, pardon me, part of the common factor is a variable. So first thing, if I look at C, well, I don't like it because it's not written in proper exponent order, which is descending, right? So I'm going to rewrite it as xy cubed minus 10xy squared plus 25xy. Now, what is my greatest common factor? xy, good. So then that would leave xy as my factor outside the brackets, and I have y squared minus 10y plus 25 inside the brackets. Well, we can factor that. So that'd be xy times y minus 5 times y minus 5. Ooh, there's an extra simplification we're going to do here. What do we call it when the same term is multiplied by itself? This right here is a perfect square. Remember in completing the square when we'd have something like this that we would then simplify down to y minus 5 squared? You factored. You just didn't know you were factoring. Okay. The next three are, well, D's a little easier. E and F are a little wonky. I'm going to work through them very quickly right now just to have it on the video because I want to get to difference of squares and I don't want to take more time than we have to sitting here blankly waiting. Okay, so go ahead and work on D, E, F. Challenge yourself. Don't look up as I work through the solutions here. You know what? It's really only F that's a bit crazy. And F, let's look at F together. This isn't something I'm going to be assessing you guys on. I'll tell you right now, I'm not going to give you crazy ones like this because, again, pandemic perk, let's call it. But just so you can see what I'm doing here. So my A value is 1. What's different is all of a sudden these exponents of 4, and there's an X and Y in the middle. Well, all that means is that it's going to be an X squared term and a Y squared term. We just don't know what this coefficient is going to be. So I can ignore my variables and I'll just say, all right, what are two numbers that multiply to 25 and add to negative 10? Well, it's negative 5 and negative 5. So that gives me x squared minus 5y squared times x squared minus 5y squared, which I could simplify as x squared minus 5y squared squared. But why does this work? Well, when I FOIL x squared plus x squared, we add the exponents, that's x to the power of 4. That'd be 5 minus 5 x squared y squared minus 5 x squared y squared, then plus 25 y to the power of 4. And then I would just simplify these to have negative 10 x squared y squared. So that's simple factoring. Let's take a look at factoring difference of squares. All we need to really worry about is square rooting here. And let's get this done, okay? So very quickly, find the square root of the following for all of these 6 terms. Square root of 9, 3. Yes, it is. Good job. Work through the rest. So I get a y squared square root of 16m squared, y square root the coefficient for 4 and the variable for m, 6h squared. Ooh, f. I like this one. So right here, 4x minus 1 squared. Well, when I square it, guess what? It gets rid of that exponent. So the square root is 4x minus 1. Done. All right. So difference of squares. What it's going to look like is, for example, ax squared minus c. B is 0. There is no b term. C has to be negative, all right? And both terms are perfect squares. So A is a perfect square, C is a perfect square when we ignore the negative sign. Can you square root a negative number? We're going to go to the examples right here just for identification first. So which of these 8 expressions meet the definition of difference of squares? So remember, A and C are perfect squares. B is 0. C is negative. X squared is a perfect square. 1 is a perfect square. It's being subtracted. Yes. Go ahead and cross out the ones that are not perfect or not difference of squares. So you should probably cross out B. Should probably cross out E, F, G, but the rest are all perfect squares. We're good. So how do we factor these? Again, step 1, always find the greatest common factor. Then step 2, what it's going to be, I'm going to write it out here. So my factor is root A plus root C times root A minus root C. So we square root them, we add, and we subtract. Let's try a couple. So number 6, I say to myself, hey, there's no B term. Could this be difference of squares? A is a perfect square, C is a perfect square, and it's being subtracted. So yes, I can do difference of squares here. So I'm going to square root each term. So that leaves me with P plus 6 times P minus 6. And I'm done. And why does this work that it gets rid of B? Well, if you FOIL it out, you get P squared plus 6P minus 6P minus 36. Well, guess what, guys? 6P minus 6P is 0. Let's try next one. Here you might say, Miss Morton, A is not 1. You said we can't or we're not going to have to factor if A is not 1. Difference of squares is. Okay, perfect square, subtraction. Great, I'm going to square root both terms. So I get 2W plus 3 times 2W minus 3. Try C, D, and E, please. C looks a little different. So we could, now we'll just leave it as this. So 7 minus 2y times 7 plus 2y. You'll add a step in next year, but I'm not going to put that in for us right now, guys. So if you're in Miss Lamb's class or Miss Rowden's class next year and they say, Miss Morton didn't teach you this, you're just going to be like, COVID, Miss Lamb, okay? And she'll be like, got it. Okay, so then I have 6a minus or plus 1, 6a minus 1. E, we're adding a new variable to the mix, but I'm confident you guys can handle that. What did you get for the answer there? Yeah, good job, Anna. So x minus 9y times x plus 9y. They're still perfect squares, even though they've got an extra variable. F, G, and H added an extra layer. Remember that our first step is actually look for greatest common factor. So here we have a greatest common factor of 3. That leaves me with 9a squared minus 1. Now I have two perfect squares. That becomes 3 times 3a plus 1 times 3a minus 1. Finish the last two, please. Okay, so G, your common factor is B. Pull that out and you're left with difference of squares. H, my common factor is 30. Wait, not 32. Need my calculator here. What can I divide 162 by? Oh, our greatest common factor is 2CD. And that leaves us with 16e squared minus 81. There's a perfect square. So 2 times c times d, 4e plus 9 times 4e minus 9. We're going to do one more type of problem. We're done in 5 minutes. Leaving this up for 30 seconds for you. You can flip over. Okay. Go on the back. We already looked at this in our beginning example of this lesson. This exponent right here and right here means that this term is a perfect square. So we still have a perfect square, and subtraction. We can still do difference of squares. It looks a little bit more complicated, but it's manageable. So same thing, I'm going to square root both terms. Now my bracket's going to be kind of big here. So in the first one, I have 3x minus 2. That's this square rooted. And I'm going to add the square root of this, which is 4x plus 1. That's my first factor. My second, I take the square root again. So 3x minus 2. This time, I'm subtracting it. 4x plus 1. That looks like a nightmare, but it is still the root of a plus the root of c times the root of a minus the root of c. And now I'll simplify. So there are invisible ones in front of all these brackets. So that leaves me with 3x minus 2 plus 4x plus 1 times 3x minus 2. Now this negative 1 gets distributed, so minus 4x minus 1. Then I'm left with not 3x. 3x plus 4x is 7x. Negative 2 plus 1 is minus 1. Negative x minus 3. And I'm done that one. Let's work through a couple more. Okay, so I'm going to square root my a term here. So that's x plus y. Then I'm going to add the root of my c term, so that's plus y, times, again, the square root, x plus y, this time minus y. Well, those ones outside the brackets just get distributed through. They're all positive 1. So x plus y times x plus y minus y leaves me with x plus 2y times x. I'm going to shift this down in, I don't know, 15 seconds. So the rest of this page, I'll tell you right now, 7, scribble that out. We're not doing it. Okay, I'm going to work through the last 3. It's just practice, so stick around. If you're feeling really good, rip through them, check your answer, and then you can go. Try the worksheets for both of these. And then on Thursday, right, we're going to look at actually putting it into action. So why are we doing all this? But thanks for popping in. If you're taking off, have an awesome day. Get outside. It's not super sunny, but we got to have something to do. Away I go. I'm going to square root both of these. So that's going to leave me with 8 minus 6a minus b times 8 plus 6a minus b. That gives me 8 minus 6a plus b. Remember, this negative sign distributes through. Times 8 plus 6a minus b. Well, and that's it. None of those can be simplified. Okay, D. Square root both of these. That leaves me with 15f plus x plus z times 15f minus x plus z. So I'm just going to distribute this positive 1 through, this negative 1 through, and I'm left with 15f plus x plus z times 15f minus x minus z. And my last one, I'm going to square root. This is going to be a big one again. So I've got 2x minus 1 plus 7x minus 4 times 2x minus 1 minus 7x plus 4. And when I distribute all of these ones through, here's the only negative one that's going to change. 2x minus 1 plus 7x plus 4 times 2x minus 1 minus 7x minus 4. And I simplify what's inside the brackets. So 9x minus 1 plus 3, negative 5x minus 5. Ooh. Now this goes a step further. Interestingly, I see there's still common factors within both of these. So that would be 3 times 3x plus 1 times negative 5x plus 1. So 3 and negative 5, that actually gives me negative 15 times 3x plus 1 times x plus 1. Woo, that's a doozy. I'm not going to ask you guys to do that on a test. You guys can stick around. I'm just going to say goodbye to the video that I'm recording. So that's it for this lesson. Go ahead and try the homework.